Hello, welcome to the NPTEL NOC Points of Topology Part 1. So, this is the final live session. So, this will be 2 hour session. So, in this session, we shall discuss some problems which we have, the concept we have learned for the entire semester, and this will be the last session. So, if you have any doubt or any question, please ask me. Don't hesitate because these sessions are for problem solving purpose. Okay, so please try to make use of this type of session. Okay. So okay, so so the question as per you can see the screen, you can read the question, try to solve it yourself. Let's wait for a few minutes and let's wait some student to join, or else we can proceed. Okay, okay, so Mustafa, are you is the screen visible to you and I'm audible properly? Please confirm. Mustafa, can you please see the screen and am I audible properly? Can you please confirm? Okay, I hope everything is clear. So you can okay. So this will last session as per everybody knows. Okay. So this final session is a 2 hour session. So if you have any questions, please ask me without hesitation. You can try to make use of this session. Okay. Okay. So the first question is as follows. So R standard denotes R with standard topology and constant R successor with the lower limit topology show that the lower limit topology is strictly finite than and strictly finite than standard topology. And from this show that the identity map is continuous, but identity map from is not continuous. Okay, so it's a simple topology. It's a basically application of basic definitions from the first principle. So please try to do it by yourself. Okay. So basically, this problem has. I mean, so here only you need to show first. Okay, the first problem. What you need to do? You need to show the strictly finite than standard topology. That is what you need to consider an open set U. You need to show that the open set is open in R dual topology. Okay, so please try, think about, and let me know. It should be done from the very first principle from topology. Okay, please take your time. Mustafa, please think about and let me know how to approach the first problem. And second problem also. In the second problem, what you need to show that. Hold a moment, please. So yeah, in the second problem, what you need to show that if you take any open set from the order stand topology, then you need to show its inverse image is open in the order equivalent topology. Okay, so please try to do it by yourself. Take your time. If not, then I will give some hint. But first, please try. Please take your time. Let me look for the next questions. Okay, so the hint are as follows. So let me give some hint. So first, it's a finite means that's what we need to show that the standard topology tau is our standard is the lower limit topology of R, right? So we want to show, and secondly, we need to show is a definition for the second problem that continuous images, pre-images, hold on a moment. Second problem to show that continuous is pre-image open, so it is open in both directions. So that's what you need to show. Okay, so that means yeah. Oh, okay. So that's what I need to show. Okay, so first try to show the first problem. That means what? You need to choose an open set to show that it is open in R lower limit topology. Okay. Now, okay. Now it shouldn't be very difficult. Please take your time, think about it. Let me know. Okay. It shouldn't be difficult. Please, please try to do it by yourself. I hope you are doing. Okay, so let me explain the problem since there is some network issue. Okay, so the argument is as follows. So the argument is as follows. So okay, so first of all, uh, so what happened? One minute. Sorry, it's my bad. Okay, okay. So first of all, observe that standard base element AB can be written as open AB is equal to close interval a comma 1 by a plus 1 by n comma b, and each a plus 1 by n comma b is a base element of Rn. So open AB is open in R with lower limit topology, correct? That means what? Any base element lies in the lower limit topology. That means arbitrary union of those base element is an element of the lower limit topology set. Now, since any open set is nothing but the arbitrary union of base element, that means what? That means that open set lies within the basis within the tau suffix L. Okay, so that is that uh, standard topology is a subset of lower limit topology. Okay, that's the first thing. And the second question is that we need to show that it's a strictly finite. That means we need to find an open infinite tau lower limit topology which is not open with respect to standard topology. Okay, so consider the set closed 0 open 1. It's a basis element of R. It's a based on R standard topology, but closed 0 open 1 is not open in R standard topology because every open interval containing 0 and 1 is not an interior point of 0 in R standard topology. So that's why you had 10. Okay, so this is the argument. Okay, is that clear? I hope it's clear. So there is nothing more to explain. So the test guard of the standard topology is a strict subset of uh, lower limit topology. And for the continuum, we need to show that R with lower limit topology, R with standard topology is continuous. Okay. For that, uh, okay, so R with lower limit is continuous. That's what we need to show. So the step one is U with open R with standard topology. So ID inverse U of U. That means what? Tau with standard topology, subset of tau with a lower limit topology. Okay. So that means what? Inverse image opens is open in the domain. So that's why it's an open. But when we show R with the standard topology to R with lower limit topology is continuous. So that means what? We need to find an open set in R with lower limit topology. So the inverse image is not open in R with standard topology, right? So same example, take 0, 1, which is open in R with lower limit topology. Its inverse image is closed 0, open 1. But closed 0, 1 is not open in R with standard topology. So yeah, so we have done. Okay. So that's the thing. So the pre-image is not open and open. So that's the thing. Okay. That means what? The finite topology has more open sets and making it easier to functionally continuous, or harder for maps to intuitively be continuous. Okay. So that's what the observation of the finer and continuity. Okay. Is that clear? I hope so. The next question is that in this question we need to find interior-closure boundary features. For each following subset R, compute the closure of the interior of a boundary. Your boundary by definition is closure minus interior. A is 1 by n, A is Q intersection 0, 1, A is open 0, 1, union 1, 2, union 3. So in this question, you have to find interior of A. So interior of means what? Of course, I will give hint, but before giving hint, let me. So interior of A means what? Interior of those points of A such that it contains the opal ball that's lies inside a hollow. That's called interior of A. And a closure of A is nothing but X belongs to a closure if and only for any epsilon. For any open set containing X, if it has the intersection A was open. Okay. So this is the definition of closure. Now use these two definitions and try to compute the interior closure boundary of these subsets of A. Okay. So please take your time, think about it, let me know. Take your time. So please try to think and please try to think it. Let me know. Please take your time. Hmm. Why not? So the hint are as follows. So this hint consists of definitions. Okay. So yeah. So please try to do it by yourself first. Take your time. So basically, what interior some point belongs to interment that particular set will contain some open ball at least. Okay. So that is the thing. Okay. So take your time. Let me know. Okay, so let me explain. Okay, so first question was A is 1 by n. We need to find it in the closed boundary. Okay, so for first of all, for all 1 by n, we consider the open interval 1 by n minus epsilon to 1 by that cannot the point is this full open interval cannot lie within it because this full interval is uncountable, but A is a countable set. So that's not possible. So the interior of A is empty. Okay, now of course, every closure of A is trivially in A. Now, question is 0 belongs to one closure of it. That means what? Why? Because take any point 1 by n, and of course, then we can find any epsilon such that that open ball that lives epsilon contains 0. Okay, so that means that closure of A is aimed 0. That means the sequence union its limit point. That's what the closure of A is. Okay, is that clear? Okay, so yeah, now boundary of A is what? Closure of A minus closure of A is A union 0, enter of A is into, so boundary of A is equal to A union 0. That means what? Every point of A union 0, it's a boundary point. And that seems quite obvious. Okay. Now, A is equal to Q intersection 0, comma 1. So in the previous part we have seen A is equal to 1 by A. Now use the same process and try to figure this out for A is equal to Q intersection 0, comma 1. Okay. And for this, what? The hint is that for this, you need to use the density of Q. That means what? You need to consider the fact that if you take any two arbitrary point, A and B, then between those two arbitrary points, you shall always find a rational number in between them, and as well as rational in between them. Well, let's not get irrational, let's stick in rational. So that will hold, okay? So please use this fact and try to figure out the boundary closure interior. Take your time. Oh, so for 2b, the answer is follows. So first of all, interior phase empty, the same argument because if we take an open interval around little q, which is rational within 0, 1, then constant q minus epsilon q plus that cannot be like inside q into 0, 1 because the counter argument. So interior phase empty. Closure. So any point x belongs to closed 0, 1, then if we take this, then any open set containing this contains a point in Q, that's a closure of A 0 equal 1. Okay. And boundary means what? Closure of this minus interior of this. So 0, 1 minus 0, 1. That means what? The entire boundary 0, 1 is a boundary in this. This is the characteristic of dense complements. Okay. That's what the argument is. So that's clear, I hope. And the next set is that what? A is 0, 1, union 2, 1, 2, union singleton 3. So please try to think and figure out boundary of a closure of interior. It shouldn't be difficult. Please take your time, think about it. Same way it will work. Okay. So yeah, that's the thing. So please try to figure out this capital A interior boundary closure. The same way which we have done in the earlier sessions, in the earlier problems. So please think and let me know. Musaf, please try to think and let me know. It's closure boundary and interior. And note that the boundary of A is equal to closure minus interior. So yeah. So please, so that's what you have in hand. So please try to use this and solve this problem. Please take your time. Okay, so let me explain. So A is the set open 0, 1, open 1, 2, and a singleton 3. Okay. So its interior is what? Interior is, of course, singleton 3 has no interior. So that means, I mean, the union of interior is equal to interior of the units. Okay. And singleton interior is empty. That's why what? Open 0, 1 and open 1, 2 because 1, 2 are open. So interior open 0 is open. Okay. Interior opens and full 0. Closure is what? Open 0, 1, its closure is close 0, close 1. Open 1, its closure is close 1, close 2. And singleton 3 itself. The closure of A is equal to close 0 to union singleton 3. So boundary of A is what? Closure of M as interior of M. That means what? 0, 1, 2, 3. These are the boundaries. So these are the four edge points. That's all. So these are there is nothing to more explain much. So the next question is an open set and closed set in subspace. So y is equal to closed 0 1 union singleton 2 is a subspace topology from R. So question is singleton y is open in y and is it closed in y? So basically here you need to use the definition of closed set. Closed set, open set means what? If you take any point, then you will get an open neighborhood containing that point contain the set is okay. And closed set means what? Its complement is open. Okay. So that's what you need to use. So please use the definition and use the basically you have to use the first principle and try to answer these four questions. Okay. Think about it, take your time, let me know. It shouldn't be difficult. Please let me know. So that is the thing. So yeah, okay. So please try it for a few more minutes, or else I will give some hint. So Mustaf, please try to solve this problem. Please think about and let me know. Take your time. It shouldn't be difficult. Okay, so the hint is as follows. Well, so A is an open set in Y. If an so now is a source source topology. A set open in the source space. If another is intersection, it's an open set. Similarly, close the intersection close subgroup. Yeah. So that's the thing. So okay, so you need to use these facts. So now try to use this and think about it, let me know. Okay, so let me explain the argument. So yeah, first of all, y is equal to 0, 1 into singleton 2. Okay. First question is what? Singleton 2 is open. That's what we need to do, correct? Now, um, A is singleton 2, open in y. So u is equal to 3 by 2, 5 by 2 is open in u. So first we take u is equal to 3 by 2, 5 by 2, and u intersection y is 2, of course. There is nothing to do problematic. Now, the in y minus singleton 2 is 0, comma 1, and take c is equal to minus 1, comma 3 by 2, closed in this. Now, since 0, comma 1 closed in y, then singleton 2 is equal to y minus 0, comma 1. So, singleton 2 is also closed, that is closed. Okay, so that's what the argument is. So, yeah, so singleton 2 is closed. Now, so singleton also, now the same argument tells that 0, 1 is a complement of 2 in closed unit both open in x and y. This shows that y is discarded and splits as 0, 1, 2. Okay. So that's what the argument is. So there is nothing much to do. Okay. I hope it's clear. Now, close 0, open half. There is minus 1, comma half intersection of y. There is close 0, open half, and it is open in y despite of this. So yeah, so that is also true. So there is nothing much to explain. And closed half, closed one. that is 1 by 4 comma 3 by 2 intersection y. We can write this as well. That is 1 by 4 comma 1, and this is not half comma 1. So in that case, what we need to check half comma 1, that is 1 by 4 comma intersection y. But in any way, y minus half comma 1, that is equal to 0 comma half open union singular 2, that is equal to minus 1 half union 3 by 2 comma 3 intersection y, which is open and y. So that is the clopen again, okay? So yeah, that's what the argument is. So so that's what this the full argument. Okay, so there is nothing much to explain. Uh, so y minus half comma 1 0 comma half union 2. That's what this open again. So that's correct only. Okay. So yeah, so that's the thing. So the next question is that the pasting lemma. So this also seems theoretical, but it's actually this can come into exam. So it will. So x equal to a union b and close f is a to y, g to y to b, and f x equal to power. And h is a map from x to y, then h x equal to fx and g x equal to y belongs to b. We need to show that h is continuous. Okay. So so that's what we need to prove h is continuous. Okay. So basically for this question, the trick is that instead of start the open set, you need to start the closed set and you need to show that inverse of closed set is closed. Okay. So that's what you need to do. So that means when you need to start the closed set which is closed in y, and you show h inverse is closed. Now we need to use the closeness of A and B in order to conclude. Okay, so please think about, take your time, let me know. So that means what you can write. Uh, what you can write C, the H inverse C is equal to H inverse A into H inverse C intersection A union H inverse intersection B. So then you have to use somehow come up with F and G. Okay, so that's what the argument is. So please think about, let me know, tell your time. Take your time. Please take your time. I shall be back in a few minutes. So you need to show that H is continuous, okay? So that's what you need to figure out. So please take your time, think about it. So let me show the hint. What happened? Ah, I see. Okay. So that's what. So the hint is that you need to choose the closest C, and the H inverse is F inverse, G inverse. So you need to say close. Subspace of is closed. Okay, so that's what you need to do. Okay, so yeah, so that's it. So there is nothing much to explain. So please think, take your time, let me know. It's closed. So you need to use yeah the definitions. Please think about, take your time, let me know. Okay, so the trick is as follows. So the point is that, so what is the target? Target is to show that the H inverse is closed for every closer C. So why that's going to show, right? So for that, what is the task we need to do? So for that, we need to, so the trick is to write H inverse C is equal to F inverse and H inverse intersection A union H inverse intersection B, right? Now H inverse C intersection A is equal to nothing but F inverse C, and H inverse C intersection B is H inverse C. That means what? H inverse C is nothing but F inverse C union G inverse C. And F inverse C and G inverse C both are being closed in X because F and B are continuous and E is a closed in this. That's why union is also closed in this. So that's why H is, the H inverse is closed in X. So yeah, so that's why you are done. Okay, and that's what the argument is. So Yeah, so that's what the argument is. There's nothing much to explain. So the fundamental thing is which are using is that the closed set is union. The and if and G agrees on a intersection with that's what we are using. Okay, so there is nothing much to explain. Please go through the argument once and make sure you understood the argument properly. There is nothing much to explain. Okay, please go through this. Take your time. Let me know. Please make sure you understood this argument very properly. Okay, so I hope you have gone through the argument and it's clear to you also. So let me go to the next question. The next question is that we need to show that open 01 is homeomorphic to R by explicit homeomorphism, and also we need to show that closed 01 and closed open 1 these are not homeomorphic to open 01. Okay, so yeah, that's what we need to show. So yeah, so basically the hint are as follows. So I need to present hint at first because without hint this kind of problem is very tricky to solve. Okay, please let me present the hint here. We're putting f of x is equal to tan of pi of x minus 2, or we may take fx equal to 2x minus 1 into 1x by 1 minus x. So you have can check that this function f is continuous surjective and it will satisfy the, I mean, of course it's continuous, so there is no confusion. Okay. So that's the thing. Okay. So okay, so try to use and also for rest of the two you have to use the hint. So that is use the definitions. Take your time, think about it, let me know. Okay, take your time. I shall have a few minutes. So the argument are as follows. So we define f is equal to 0, 1 to r, f of x equal to pi of tan of x minus half. Okay. We need to show what if is continuous, surjective, bijective, as well as both and bicontinuous. Now, first of all, if map 0, 1 to r, how? Because if x belongs to 0 plus pi of x minus half, then the minus by weight on f of x goes to minus infinity. And similarly, we can show that f of x is going to plus infinity, x is going to plus. So by intermediate value theorem, if is surjective on r, and if it's strictly increasing on r, because derivative is x square pi of x minus half, so strictly increasing function. Okay, and if it's continuous because composite continuous is continuous. If it's strictly monotone and continuous from interval on to continuous, so that's why if it's homeomorphism. If it's continuous and so okay, so that's what so this argument is basically a problem real analysis. That means what? In your okay, so possibly those who are attending this course, maybe many of you will go to PhD, and there in the in what in qualifying exam, this question may come that construct explicit homeomorphism 0 1 to r, or maybe they will give this function and ask you to prove that it's surjective. Okay, so yeah, so this particular question is a good question for basic real analysis. Okay. Okay, think about it, take your time, let me know. Now, close 01 is not homeomorphism because directly one can show that one is compact, other is not. Of course, there is no point of being homeomorphism, right? So there is nothing much to explain. So that I have wrote the argument. Please go through the argument once, then we'll go to part C. So yeah, so that's what the argument is closed zero and open one. So there is nothing much to explain, I hope. So the next point was that closed sheet open one is not homeomorphic open zero open one. The point is both are not compact, so simply compact another argument will work, but it is connected because if we remove the point 0 from left side, that's from domain close 0 open 1, then they need to be open 0 1, which is connected. But if it simply remove any point from the open interval 0 1, it will be disconnected. So that is why these two things are not homomorphic. Okay. I hope this is clear. So that's what the full argument is. Okay. So the next is that's what the argument. So please go through the argument once. Then I shall go to the next problem. the pi1 x cross y2 x with first color projection. Okay, so we need to show that pi1 is an open map, and we need to show an example to show that pi1 is not a closed map. Okay, that's what the argument is. So yeah, so please think about. Let me know. It shouldn't be difficult. It will be just basic. I mean, at least pi1 is open. It shouldn't be difficult. What you need to do? You need to take an open set from x plus y. Now that open set can be written as union of base element, and you need to use the pi1 as the base element. How the base element of the form u cross v, and pi1 of v cross v is what u. So that's open. So yeah, so that's the argument. Please think about. Let me know. Take your time. Hmm. Okay. Okay. So yeah, okay. So we need to show the pi1 is an open map. Okay. So the hint. Let me show the. So basically, since I mean, so if you're enough, if we are, it's enough to show that by one maps basically where you cross between opens it. Then also we are done because any opens in a unit of you cross, right? So basically, it is enough to show that pi maps the basis element to the open set object. That should be enough, right? So yeah, so that's what we have proved here actually. And then we gave an example of the pi is a closed map. Okay, so there is nothing much to explain. Okay, so yeah, so that's the argument. So please think about it. Take your time. Let me know. So yeah, that's what I'm going to show. Please try actually back the moments. So let me explain the argument here. Just hold on, everything will be fine, and let me check here. So the argument goes as follows. First of all, in order to show that pi is open, we choose an open set W sub of x plus y, and we'll show that phi 1 W is open in X, right? Now the point is that in this step 2, Basically, the story of this step to the step 3 is that any opens a W is nothing but arbitrary union of basis elements, right? Now, the basis elements are of the form U cross V. So basically, W can be written as arbitrary union of U cross V. Now, pi 1 of U cross V is U, which is open in X. That means what? Pi 1 of W is an arbitrary union of U's, which are open in X, correct? So that means what? Pi 1 W is open in X. So that means pi 1 is an open bar. Okay. And the next thing is that in order to show parents a closed one, choose the set C is equal to xy such that xy equal to belongs to R. C is equal to f inverse 1 and, 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 and pi 1 C is equal to x plus 1 by x union 0. So that is not impossible. So that's so R minus 0 is not closed in R. So that's what the full argument is. So there is nothing much to explain. So please go through the argument once and let me know. Then we shall go to the next question. Oh, so I hope this is clear. So there is nothing much to explain. So okay, so yeah. So this particular problem tells if pi one is open, maybe it is not closed. Now the question is when it's closed. So we have done an exercise that if the second space that is y is compact, then pi one is closed. Now later on we will see this. Okay. Now this particular problem. Hold on a moment, please. Let me show you. This particular problem is delta is x cross the diagonal. We need to show that x, how's the equation of delta is closed in x cross. Okay. So yeah, so just try to do it by yourself. Take your time. Let me know. It shouldn't be difficult. Please take your time. So there is nothing to give hint. Also, you have already we have seen this particular problem many times, right? So please try to do it by yourself. Please take your time. Basically, what you need to show 1 minute. Basically, we need to show that x is house drop, then delta is closed, and vice versa. So basically, you need to show that delta its complement is open given the fact that x is house drop. So I hope you can do it by yourself. Please take your time. So one direction is also when you show that it's closed, that is completely open. That means so you need to take a point x y with x not equal to y. You need to take show that the direction opens at u such that u intersection delta is empty. Okay, so the hint is as follows. So please use the hint and try to solve it by yourself. So anybody will do it? So the argument is as follows. So assume that x is house room. Okay, we need to show delta is closed. That is equivalent to what we need to show. We need to show x squared minus delta is open, right? Now take a point x comma y from x squared minus delta. That is x not equal to y. Okay. Now since x is house drop, there is an open to the u and v, so the u intersection v is empty. Okay. Now u cross v is open in x process, product opens. So we need to show that u cross v sum of x cross x minus delta. Now indeed, if a comma b belongs to u cross v, and since u intersection b is empty, then a not equal to, so a comma b does not belong to delta. Okay. So that means what? Every point of x cross x minus delta has an open neighborhood contained in it. That means what? X cross x minus delta is open. That means what? X is closed. So that's what the argument is. Okay. So that's a trick of solving this kind of problem. There is nothing much to explain, to be honest. So I hope this clear. So please go through the argument and convince yourself that it's correct. Okay. So okay, so take your time, let me know. Then I shall go to the next problem. Okay. So I hope this argument is clear. So yeah, so basically this is one direction, the house window is closed. Now let me prove it the another direction, really closing the house door, right? So we assume the delta is closed. That means x cross x minus delta is open. Okay. Now choose x comma y belongs to x with x not equal to y. Now then x comma y belongs to x cross x minus delta. Now since x cross x minus delta is open in the product topology, there exists x y belongs to u cross v, which is our x cross x minus delta. So it is by definition that u cross v is our x cross x minus delta, right? In that case, x belongs to u and y belongs to v. Now, since u intersection v empty, if z belongs to u intersection v, then z cross z belongs to u cross v, sub of x cross x minus delta, which is a contradiction. Okay. So that means what? X is housed. Now if x to y is continuous, of y is housed from the set x belongs to fx going to gx is closed. So now the point is x going to f is continuous y cross y because it's closed in its inverse image delta y is going to close. So that's what the argument is. So I hope it's clear. So there is nothing much to explain.
Yes, yes, it's clear.
Okay. Thank you, Mr. for the confirmation. Okay. So please go through this full argument once again. Or if it is clear, then we share. Okay, so we have initial clear. So let me go to the next problem. The next problem is as follows. X divided metric is we need to show that prove so x is first countable, and in that situation, we need to show that every point x has a neighborhood base is called x. Okay. That means what? We need to choose a point x and to show that we can find a basis around that point which is countable. That's all. That means basically wanted to show that if you take any open set containing that point, that open set can be put inside in one of those countable bases. So that's what I do. Okay. So please use the definition of metric. Think about it. Take your time. Let me know.
So a space is first countable if
Yeah. Continue, please.
a space is first countable if every point has a countable neighborhood basis.
Correct.
For any point x in a metric space,
Correct.
the set of here I take the x in a metric space, something x or d distance, and the set of balls actually b of
Mhm.
x comma 1 by n with a radii where radii is r is equal to 1 by n for n belongs to natural number constitutes a countable local base. For any
Correct.
open neighborhood U
Mhm.
containing X, there exists an epsilon greater than 0 such that B of X comma epsilon is
Mhm.
subset of U. By the Archimedean property, there exists an integer n such that 1 by n less than epsilon, meaning
Mhm.
B of x comma 1 by n subset of b of x comma radius epsilon the subset of u.
Correct. Absolutely correct. Very good. So, yeah. So, let me explain once again the argument. So, basically, that's what you have explained. So, please go through the argument once and check everything is clear. And also, basically, we have taken the metric d and we are considering the ball of 1 by n radius 1 by n around the d ball around x, and we're considering all those such b 1 by n. And if any open set contains an can we count the inside this full bx 1 by n solve. So there is nothing much to explain. So please go through the arguments uh, and check it's clear or not. Okay. So let's wait for one moment. Okay, so I hope it's clear. So let's go to the next problem. The next problem is as follows. So it's uncountable set cofinite topology, and we are writing a talk of. So check the following properties that separable first countable second countable. Okay. Okay. So yeah. So the first of all, the separable means what? It has a countable tensor. We need to find a dense countable set whose closure is X. The first countable, second countable, it is a countable basis for topology. Okay. So let's check one by one. So what happened? So D sub. So basically, so in tau of 1 minute. So basically in tau of uh, so in tau of U is open if U satisfies X minus is finite. That's so U is co-finite. So it only measures finitely many points, right? So that means what? Any infinite set is dense. Why? Because if you take any non-open set, so the infinite set cannot lie entirely contained in a finite set, of course. That's obvious. So it must contain some infinite part also. So that's why U intersection D must be non-empty. So in particular, any countably infinite set is dense. Therefore, X comma tau of is separable. Okay. So now for the second one, Chook x belongs to a countable base un. And now since each un is open, so fn is equal to x minus a finite. And then x equal to intersection un, and where intersection un is the union of f of a countable union of finite, so it's countable. Now intersection u is co-countable. So intersection of un contains countable many points beside x. Now choose a y belongs to intersection of un with y not equal to x. Now open set v equal to x minus y contains y not equal to v for any x. And this contradicts the fact that un being local basis of x. Okay, therefore x comma tau of is not first countable and even not the second countable. Why? Because the same argument follows. It's not second countable. So basically, go through the argument and make sure you understand the argument properly. So there is nothing much to explain through words. So it's already written. Please go through the argument once and make sure you understood it properly. Okay. I shall get back to you after a few moments. Okay. So I hope this argument is clear. So now let me go to the next thing, next question. So this question is that about the product of second countable. So this question is that if x and y are second countable, the product second countable. So of course it is the hint should be sufficient that if you take u and a vm to the basis, then increment vm is countable, and the question is that even interpretation should work. So there are two things to define: is it countable and whether the base is, that's all. Okay. So please think about and let me know, Mr. Mustafa. Let's think. I mean, there is really nothing much to explain. It's just a matter of checking. Hmm. So now since the UN and VN are countable, so of course UN cross VN is countable, so there's nothing much to explain. And I mean that is obvious. We need to show the basis, right? That means what? We need to take an open concept U, and we need to show that some UN and VN should lie within this, right? How this works. So the point is that base now since if you take a product U and V and open now since X is U and V, so X belongs to BUX and Y belongs to VM. So X belongs to UN cross VM and UN cross VM belongs to B. So that's why the thing is since B is a countable base, X cross Y is second countable and R is second countable, so this does the job. Okay, that's all. So that tells the RN is same. I mean, so that's what the argument is. So that is yeah. So that's the argument is okay. So yeah. So that is the argument. So yeah. So I hope this argument is clear. And yeah, so now and corollaries are countable and yeah, and p comma q p comma is a countable basis. So it's on one of the corollaries. That's maybe interesting for some of you. The whole and everything will find out. Yeah, check yeah. Now question 11. So in this question, the question is as follows. So x is uncountable to cofinite topology. We need to show and prove that t is x is t1. T1 means x is t1 and it's not Hausdorff. Okay, and gives a concrete example t1 not equal to Hausdorff. T1 means what? Every open set contains a every point contains an open set not contiguous. That's a T1 space. Okay, please think about. Let me know. Take your time. If there is nothing difficult, please take your time. I still have a few minutes. Okay. Now the point is that, hold on a minute. Okay, so the hint as follows. So basically T1 missing is close to show. So that's what we need to show. So point is that in cofinite topology, what are the opens? Open set whose complement is closed, correct? So that means what are the closed set? The closed set is the complement of open set. That means closed set are precisely the finite set, right? And X is not Hausdorff. We need to show that means what? If we take any point X and Y, then we must have U intersection V empty. That means what? U complement, V complement is full of X. Now U is open, V is open. That's the U complement finite, V complement finite. The union is also finite. So U union V equal to X, such an equation is not possible. Okay. So yeah, so that's the thing. I hope this argument is clear. So there is nothing much to explain more. Yeah. So that's the counter argument itself. So there is much. Okay. So order of V less than equal to M, which is less than epsilon as a contradiction. Yeah. Okay. Now the next question. Okay. So please go through the argument once and make sure you understand properly. Then we can go to the next question. Okay. So I hope this argument is clear. Let's go to the next problem. So this problem deals about the uniqueness of limit. So in a house structure, every convergence has a unique limit. And also this equation Hausdorff uniqueness. That means what we did are the cofinite topology in a space which can Hausdorff and every sequence, any sequence converts to any of the point. That is why a convert. I mean, okay. So yeah. So please try to prove it. Hausdorff space every sequence has a unique limit. Has at most one limit. Please think about it. Take your time. Let me know. So yeah. So the thing is, argument as follows. Now, suppose X is house trap, okay? That means what? So suppose X belongs to L1 as well as Xn belongs to L2. So that means there are natural N1 and 2 belongs to U and B such that X. That means Xn belongs to U as well as Xn belongs to B. Now we can take max equal to max of N1 point, and that gives Xn belongs to U intersection B. And that's not possible because the U or V are pointed in such a way that U is empty. So that's what the problem is. Okay. So that says that Hausdorff space N is converges to the unique limit. And this particular counterexample tells that if we take xn equal to n converse every point, the L belongs to arbitrary and L belongs to U, then U is open in tau cofinite or the complement R minus U is open. Then the set n belongs to n, so the xn equal to n not equal to U equal to subset finite. So xn doesn't belongs to U for at most finite limit equivalent xn going to L. Therefore, xn going to L in tau cofinite topology. Now, since x is arbitrary, so xn equal to n converges to every real number. Okay. So please go through the argument once. So there is nothing much to explain. Okay. So I mean it's clear actually. Okay. So this particular part is interesting. The every metrizable spray X is normal. That means what? If we take any two closed sets, then we can find open set containing those closed sets which are disjoint also. Okay. So yeah, take your time, think about it. Let me know. So yeah, so that can be done in this way. So there is. So okay. So it's a quite tricky problem. So A belongs to define epsilon and DAB, then we consider infimum of the distance and take U to be BD and epsilon A by 2 and V to be BD, B comma epsilon B by 2 and then you know when balls then clearly X belongs to A sub of U and B sub of U. Okay, so you may go through the argument once, you can take the screenshot of that. So that's the argument, okay. And also U intersection B empty because if U intersection not empty, suppose Z belongs to U intersection B, then Z belongs to BD of A comma epsilon A by 2 for some A belongs to A and Z belongs to BD of B or B by 2 for some B belongs to B, then rest of the thing is work. Okay, so that's the argument. So there is nothing much to explain more. Okay, so okay, so that's what time now. Okay, that's all for today. We shall. Okay, so all the best for your upcoming NPTEL final exam. I hope this session is useful for you. If you have any doubt or any question, please drop an email. I'll definitely get back to you as soon as I can. Okay. Thank you for your time, and I hope you enjoy the course a lot. And I hope some of you may enroll in this part topology course. Okay. Thank you. Wish you all the best.